Hey folks, welcome to video number 2, working our way through the chapter review for the trig chapter, trig part A anyway. We'll continue with trig when we're done with this one. Alright, so let's get to it. Number 6, very simple question, if you remember that this is indeed a special right triangle. So take note of the fact that the side that we have labeled is the one that often, if the other numbers are nice easy whole numbers, this is where the square root of 3 belongs. This is the medium length side. Again, hypotenuse is longest, and the side across from the 30 is the shortest. So the quick, simple connection here is the side across from the 30, or the short side, is simply the number on the medium side divided by square root of 3. So basically we drop the square root of 3, we have its value. For the hypotenuse, it's double the short side, so of course the short side is 4. Easy answer here is 8. So of course we'll just transfer the answers over to here. Not really any work to show on this guy. Also they asked for the other degree measure, of course, simple 30, 60, 90 triangles pictured here. So again, knowing those values and the connection makes some of this work go very fast and very easy. For number 7, you see the lovely picture. And here we've got somebody walking their way 40 feet away. And it says the angle of elevation from that person's perspective now up to the top of the tree. They elevate their eyes through this angle of 70 degrees. So we get the picture set up correctly. Again, the height is what we're solving for. And because trees in general we can assume grow perpendicular to the ground, we have a 70 degree. There would be a 20 up here if you'd care to put that in. Right triangle, which means, hey, sweet, right triangle, all we got to use is SOHCAHTOA. And it looks like I have enough info to do that. So again, take note of your starting angle, 70 degrees. The piece we're looking for is opposite. The piece that we have a number for here is the adjacent side. So I said opposite and adjacent. Which of our three functions does that use? Of course, if I remember TOA, that means I need to use tangent. And that's always the tangent of some angle. Equals opposite side, I chose an H today, over 40. And now this one's super quick to solve, simply multiply both sides by 40, of course. Final answer should be, for this one, about 109.9 feet if we care not to round to 110. That would have been okay as well. And there are trees that are this tall, so that does fall within the realm of reality. For the last one on this particular short video, we'll bring in actually, let's get rid of that. I don't want to keep all that stuff there. Make a brand new picture for ourselves. So, we have a rectangular yard. I'm just going to picture part of the corner here. And it says she's going to keep a tree in this section for the dog to be able to play around and access. She is going to add a fence and cut off a triangular region here. Okay, so this is what she's going to do. Her yard could be bigger. This red line could be a full diagonal. Doesn't make much difference in our picture. We're trying to get the idea. So, sentence 2, in order for the tree to be included, one side needs to be 14.5. They don't tell us which side should be 14.5, so I will just pick one. I could have also chosen the other. It says one side needs to be this long, and that side will make a 53-degree angle with the new side. The new side here in red is the one she's adding to make the pen. So the angle between the side I chose for 14.5 and the new one makes a 53-degree angle. That must mean the angle is here in this corner. Had you chosen this side up here at the top to measure 14.5, the angle between that and the new side would have shown up above in the other corner. Again, right triangle, SOHCAHTOA is really all that's needed to keep things easier for us. And the pieces we have, notice I have, if my angle is 53, I have a side here adjacent. This is our fence. We would call that the hypotenuse, of course. So, if I have adjacent and hypotenuse, and I remember SOHCAHTOA, cosine is the one that is in play in this problem. 53 degrees of cosine, or rather cos of 53 degrees, equals adjacent over hypotenuse. And now to make these easier, when that variable, that letter f, is in the bottom corner underneath, it's useful if I write this over 1, so I can basically turn this into a proportion. And I'm hoping we all remember, with my lovely Christmas color set here, that proportions are solved by cross multiply. So f times cos of 53 equals my 14.5. And from there, to get f alone, we of course divide by the cos of 53. This should generate my answer. And before I grab my calculator, just thinking out loud, this 53-degree angle is bigger than the one over here. So I'm thinking the side across the way, it's going to be bigger than 14.5. I'm going to wild guess that maybe this is 30 feet long. Punching into a calculator, it actually turns out that the length here is 24.1. So my estimation was a little bit off, but that's how it goes. 24.1 feet for question 8. The tricky part for this one is getting the angle in the proper corner, of course, so read a question like this carefully to determine. It does very specifically say we want the angle is formed between one of the sides and the new side. That's fairly easy to figure out. All right, cool. Video 3 will contain several other questions. Exit tunes for you. See you on the other side.